there. I'm super happy to be teaching you again. I know I always start off my notes with saying something like that, but it's really the truth. I'm very fortunate in that I love working with you guys. I totally love being a math teacher. So anyway, we already finished our 1.3a notes. Today we're going to do 1.3b. They are from the same section of the book, but because each topic is so important and kind of unique, I like to teach them as two separate lessons. So at the top of your notes today, you're just going to write 1.3b. Now the problems that go with these notes will be on the same worksheets that you already started working on after doing your 1.3a notes. So it's going to be your 1.3 practice A, your 1.3 practice B, and then your 1.3 puzzle time worksheet. And the directions, of course, for which problems are which are on your assignment sheet. Okay, so last lesson was about the distance formula. The formula that we're going to learn about today is the midpoint formula. So at the top of your notes, next to 1.3b, write the words midpoint formula. That's what we're going to be learning today. Now, this is kind of a personal opinion, but I think that this formula is a little bit easier than the last one that we did, than the distance formula. I'm going to give you 4 examples after giving you the formula, and then that'll be our notes for midpoint. So as I mentioned with the last lesson, if this were an in-class situation, I would probably put more details in the notes, but I'm trying to streamline these videos and get you the rest of the information during Zoom, so it's not too much all in one place. So in terms of what the midpoint formula is, you're going to write a big set of parentheses, and then you're going to have x1 plus x2 over 2 and y1 plus y2 over 2. You might need to zoom in on that. You do want to have the little subscripts here, the 1 and the 2 on the x's and the 1 and 2 on the y's, and then the whole, each sum here needs to be over 2 or divided by 2. So we're going to do a few examples to kind of illustrate what this tells us, but essentially if you have 2 points in the coordinate plane, you want to find the point that's exactly in the middle of those 2. So let's draw 2 points and go from there. Let's go ahead and draw our XY axis. So we'll put the X on the one that goes left to right and the Y on the one that goes up and down. And we're just going to be graphing one of these. So again, if you have graph paper, that might help a little bit, but it's really not that necessary. The first point I'd like to plot is the point 2 over and 5 up. So I'm going to go 2 over and then 1, 2, 3, 4, 5 up and put a dot, and I'm going to label it 2, 5. And I'm also going to put an X and a Y underneath there. The other point that I'd like to plot is the point -4, 3. So I'm going to go 4 to the left and 3 up and put another dot, and I'm going to write -4, 3 with an X and a Y below that. Now it's kind of up to you which point is your first point and which one is your second one, just like it is with the distance formula. I usually put 1s on the one on the left and 2s on the one on the right. And I think what I'm going to do to make this a little bit easier to see is label my point a little bit higher up just so that it's not in the way. There we go, and put the 1s on there. Okay, so essentially what we're trying to do is we're looking at this segment right here that joins the 2 points, and I want to know where is exactly the middle of that blue segment. So I need to plug all of the numbers into the midpoint formula. So I need to find x1. Can you go ahead and look at your graph and see if you can figure out what x1 is? So x1 is -4. So I'm going to write -4 plus, and then x2 is 2. So -4 plus 2 over 2 is going to be the first part of my formula. Now look for y1. y1 is 3. So I'm going to have 3 plus 5, because 5 is y2 over 2. Now let's do our work with positives and negatives. To figure out what -4 plus 2 is, I start at -4 on the number line and go 2 to the right, and you can see that I end up at -2. So this first coordinate is now -2/2. 3 plus 5 is 8, so this is 8/2. The last step for me here is to simplify. Any number divided by itself is 1, but because of this negative sign, this becomes -1/4. Let's go ahead and put that on the graph and see where it ends up on this blue line. If I go 1 to the left and 4 up, you can see that I end up right there, and that does indeed look like it is at the middle of that segment. That is our midpoint. So that's the first example using a graph. Now technically you don't have to have a graph, but I wanted you to have a visual on that. And like I said, we're gonna do 4 examples today, so let's have that be our first one, example number 1. Now, oftentimes teaching this in class, I might do a couple more examples just to give you the opportunity to really absorb this. Because this is on video, if you wanna pause this, rewind it, and play it again, you can do so. What I'm going to do now is show you a slightly different variation of the formula that I do think is harder, but it is something that comes up a fair amount. So with the original problem I just gave you, we could just plug it right into the midpoint formula because we had both endpoints. What will sometimes happen is that you'll be given the midpoint and one endpoint, and you will have to find the other endpoint. So in that case, this formula, while we could technically use it, I think it's much easier to do using an alternative method. So in fact, just to make this a little bit more clear, I'm just gonna even erase the formula because I'm gonna show you how to do this kind of problem without the formula. So we're gonna label this example 2. And what we're gonna write down is find the coordinates of D if E, which is at -6, 4, is the midpoint of DF and F has coordinates -5, -3. Now that's a mouthful. You might want to pause it and kind of write that down. But we're trying to find the coordinates of point D if E is the midpoint and we have the other endpoint F. Now personally, even though I teach math, I have to say I like to have a picture when I'm trying to solve this. I personally would find it hard to do without a picture. So I recommend that you draw a picture, and it doesn't have to be perfect. But they're telling you that there's 2 endpoints, D and F, and they're also telling you that E is in the middle. So you just want to draw segment DF with E in the middle. Now we've been told that E is at -6, 4. Now this doesn't have to be in the coordinate plane. You can just write this just the way I am here. And we've also been told that F is at -5, -3. The question is, when they say find the coordinates of D, what they're really saying is, what are the X and Y that go with D? And so there's a way we can do this visually that I think is a lot easier than trying to use the formula. So I'm gonna show you that method. What we wanna do first is, let's, for example, take a look at the X coordinates. Keep in mind that E is exactly in the middle. I know that to get from F to E, looking at the X coordinates, I'm going to start at -5 and go to -6. So if you look at the number line and I'm at -5, to get to -6, I would have to go 1 to the left. So I am subtracting 1. So I'm going to make a little note of that here. I'm going to say subtract 1. To go from -5 to -6, I'm going to subtract 1. How much do you think I would need to go if I can get from one end to the middle by subtracting 1? How much do you think I would need to go to get from the middle to the other end? if you said one more to the left, you're 100% correct. We would go one more to the left. So let's look at the number line. If we are at -6 and we go one more to the left, we end up at -7. So I'm going to write in -7 here for the x coordinate of my endpoint. Now that gave me my x's. I still need to find the y coordinate. So let's look at the y coordinates. To get from the end of the segment to the middle on the y coordinates, I'm going from -3 to +4. Well, let's see how far we would have to go to do that. If I started out at -3, first of all, I'd have to make it all the way to 0 by going 3 spots. Then to get to 4, I'd have to go 4 more. So I'm going 3 spots from here to here, and then 4 more. I am going 7 spots to the right. So I know that to get from -3 to 4, I have to add 7. So using the logic that we talked about a minute ago, if I have to add 7 to get from the end to the middle, what do you think I would have to do to get from the middle to the other end? I hope you said add 7 more, because that's exactly what you would do. You would add 7 more. So if I start out in the middle at 4 and I add 7, it would become 11. Now, most students hate this example. There's negative signs, you're not using the formula, and some of them are kind of stressed out, like, how do I even know if I did it right? The cool thing is, once you actually have the 2 endpoints figured out, you can use the formula then easily to check whether or not you've gotten it correct. You would add your 2 x values of the endpoints together. So -7 and -5 over 2. And then you would add your 2 y coordinates, 11 and -3. And divide those by 2. Now -7 minus 5 is -12. 11 minus 3 is 8. And so we can see the answer to this is -6,4. Now this is just kind of extra work that I did here. It's not necessary. We're checking our work. Now the thing is, it's no coincidence that this -6,4 is this same value, the same coordinates we had here, because if we figured out this endpoint correctly, -6,4 should be our midpoint. So it's a kind of just a way of checking our work. We're assuming this is the endpoint, and we're checking that if we find the midpoint, we do indeed get the midpoint, all right? So that's the worst part of the notes. I'm sorry you had to deal with that, but it is a really common problem that comes up. Okay, the next thing that I would like to do is also, not an easy problem, but it is one that we can totally manage together. It's a picture of a segment, and they're asking us to identify something called the segment bisector. Now, bisect is a word that we are going to talk about a lot this year. To bisect something means to cut it in half. So if I gave you a ruler and I told you to bisect it, how long do you think each of the 2 pieces would be? Each piece would be 6 inches long, right? Because a ruler is 12 inches. If you bisect it or cut it in half, you have 2 6-inch pieces. So to bisect something just means to cut it in half. So let's do a picture here again. This is example number 3. And we're supposed to identify the segment bisector. So we have segment AB. We're going to call the midpoint M. It doesn't have to be called M, but we are. And this is a good review, by the way, of some of our material from notes 1.1.1.2. How do you label geometric points, lanes, and planes? We're labeling this line segment with capital letters. I'm going to call this line L. And remember, if I just use one letter to describe a line, it has to be an italicized lowercase letter. So that's why I'm using line L here. So if I wanted to know what is the segment bisector, what would that be, do you think? What geometric figure is bisecting the segment? It would be line L. So line L is the segment bisector. All right, now, what we're going to do for the second part of the problem is find the distance from the endpoint to the middle. In this particular problem, I have one segment of length 4x minus 1, another segment of length 3x plus 3. So if I took a ruler and I asked you to bisect it, and I asked you how many inches long is each segment, and I told you it was 6, how do the two pieces compare in size? They're exactly the same, right? So if we bisect something, we can put little tick marks here. That is our way of saying, hey, these segments are exactly the same length. So that means I can take this algebra expression, 4x minus 1, and set it equal to this algebra expression, 3x plus 3. Now, some of you are more comfortable with solving equations than others, so I'm going to go over how it is you would go about solving this equation. We want to get the x on one side, so I'm going to subtract 3x from both sides. 4x minus 3x is x, and I'm going to bring down the other information. Now I want to use opposite operations. What is the opposite of subtracting 1? It's adding 1. So we get x is 4. Now in geometry, I hate to tell you this, probably you're already kind of getting this fact in your head, but we oftentimes have more than one step to finish the problem. Because in this particular problem, the question was, find AM. Now, from one of our very first lessons, you may remember that when we have two capital letters next to each other in math, that is the equivalent of saying find the distance between A and M. We have done all of our work correctly. We know that x is 4, but to find the distance from A to M, I need to plug 4 into x. So I'm going to take 4 times 4 minus 1, 16 minus 1, which is 15. So if I wanted to find the length of AM, it would be 15. So that was kind of a hard problem, but again, the reason I have it up there is there's one like that in the homework. All right, one last example. I told you we'd be doing 4 examples today. That was the third one. This one also uses some algebra skills. So some of you are going to be more comfortable with it than others. But again, what I would like to do to help you guys out is be reviewing algebra concepts with you throughout this school year. So this is now our last example, example number 4. And we're going to draw a segment here. And after this, we'll be done with our notes. Segment P, Q, R. And the question says, find the measure of PR if Q is the midpoint. And I'll write this information here. PR equals 14x plus 2. And QR equals 6 minus 3x. Now again, two capital letters next together are a way of saying distance between. So the distance between P and R is 14x plus 2. And the distance between Q and R is 6 minus 3x. Now some of you are thinking, we can't solve this problem because we don't have all the information. This is actually a great problem. It pulls together a bunch of lessons. We did talk about the segment addition postulate earlier. And what that tells us is we can take the two pieces of a segment, add them together, and get the length of the whole thing. This also uses the term I just introduced to you a minute ago, the term bisector. If this segment is bisected, in other words, if Q is in the middle, then I know that each of these halves is the same length. So can you think for a minute and tell me, if the distance from the middle to the end is 6 minus 3x, what does the distance from the middle to the other end have to be? It also has to be 6 minus 3x, right? So we know these two lengths are the same. Now, can anybody on your notes figure out what equation would I set up to solve this problem? Take a look at your picture. Like I said, zoom in if you need to. But I'm wondering if you can tell me what the equation would need to be to find x in this problem. Okay, hopefully a couple of you may have started the equation. I'm going to take both pieces, add them together, and set them equal to the length of the whole thing. So 6 minus 3x plus 6 minus 3x equals 14x plus 2. This is a great opportunity to practice solving equation skills from algebra. Let's combine like terms. So I'm going to take 6 plus 6 and get 12. And then I have negative 3x minus 3x, which is negative 6x. And then I'm just going to bring down the right-hand side just the way it is. Okay, let's move the x's to one side. I'm going to add 6x to both sides. So now I have 12 equals 20x plus 2. I'm going to subtract the 2 and get 10 equals 20x. Now let me pause so you can catch your breath a little bit, and I want you to see if you can figure out how to finish that part. This is our last example. We want to do opposite operations. Opposite of multiplying by 20 is dividing by 20. 10 divided by 20 is the same as 1/2. So x is 1/2. Now, unfortunately, we're not done. They wanted us to find the measure of PR. Well, PR, the length of the whole thing, is 14x plus 2. So let's write that down. PR equals 14x plus 2. What I need to do is take the 1/2 that I just got and plug it in for x. So I'm going to take 1/2 and put it where x is. So I'll have 14 times a half, or half of 14, which is 7. I'm going to bring down my plus 2, and I'm going to get 9. So it looks like the length of the entire segment is 9. That's it, guys. We're done with all of our 1.3 notes. We've done 1.3a, 1.3b. And so now you should be looking at your assignment sheet to see what remaining problems you have left on your 1.3 practice A, 1.3 practice B, and puzzle time worksheets. And then we'll go over them during Zoom. Thanks so much. Bye.